All right, chapter 2 is all about solving equations. And of course, when we solve equations, we want to be using the 5 properties of equality. So let's go over what those are. The first was the transitive property of equality. When we talk about transitive, we're talking about if A is equal to B and B is equal to C, well, we can forget about B and say that A is equal to C. And we see that a lot. All throughout mathematics. Let's look at the addition property. The addition property says that if A is equal to B, well, A plus X should still be equal to B plus X. We're adding the same thing on both sides. They are still equivalent. That's what we refer to. Some teachers will call it the golden rule of math. What you do to one side, you do to the other. It does have a specific name, and that would be addition, subtraction, multiplication, or division property of equality. And each of these follows the same pattern. So if A is equal to B, well, A minus X is equal to B minus X. Multiplication, if A is equal to B, A times X is equal to B times X. And division, if A is equal to B, then A divided by X is equal to B divided by X. So let's look at the bottom here. I've written out some pieces of a proof. Let's finish that proof together. We start by the given information. 2x plus 5 is equal to 6x minus 11. That's our given. The next step that we have is 2x equals 6x minus 16. That 5 has moved to the other side, and we would use the subtraction property of equality. Does that fit here? Kind of. The subtraction property of equality to show that. Step 3, we've taken that one step further. The 6x has moved to the other side, again through subtraction. 2 minus 6 gives us that negative 4, so this is the subtraction property of equality. Our final step here, x equals 4. Well, how did negative 4x become positive 1x? Through division, so that's our division property of equality. Let's have a look at another proof. This one involves 2/3 x plus 4 equals 10x plus 2. That's our given information. Now our next line is very different looking. It says x plus 6 equals 15x plus 3. Well, how did we get that? Well, notice this 2/3 x, which was kind of the problem in the last equation, has now become a very nice 1x. How did we do that? We multiplied every piece of this by a specific number, and the number that would get rid of 2/3 would be 3/2, 3 over 2. So we're going to multiply each of these terms by 3 over 2. 3 over 2 times 2 over 3. We chose 3 over 2 because this cancels. 3, 3, 2, 2. We're left with 1x. 3 over 2 times 4. 4 times 3 is 12. 12 divided by 2 is 6. Also, 3 over 2 is 1.5. So 1.5 times 4 is 6. 3 over 2 times 10. 10 times 3 is 30. 30 divided by 2 is 15. 3 times 2 is 6. Divided by 2 is 3. Notice this 2 is really 2 over 1. So these 2's cancel. We're left with 3. So now we have 1x plus 6 equals 15x plus 3, and we would use the multiplication property of equality to get us here. Our next step, this 1x moves to the other side. That would be the subtraction property. We now have 14x. Then here, the 3 moves to the other side via, again, subtraction. And 14x becomes 1x through the division property. Now at the end of each proof, we should be writing Q, E, D. To show that we're done. I actually didn't do that on the last proof, so I'm going to go back, and I'm sure some of you noticed. I'm going to write that at the bottom here. All right, this last one here for our proofs is a little more complicated because we're given 2 pieces of given information. X is equal to 2y minus 4, and 3x plus 6 is equal to 2y plus 4. Did I say minus? I meant plus. X is equal to 2y plus 4, and 3x plus 6 equals 2y plus 4. Now notice that they're both equal to 2y plus 4. Well, that looks a lot like the transitive property. It's already written here. If 2 things are equal to a third thing, those 2 things are equal to each other. And we see that x is equal to 3x plus 6 via the transitive property. Then the 6 moves to the other side, a positive 6. We subtracted 6 from both sides. We ended up with a negative 6 here, subtraction property. Then this x goes over there. Again, subtraction, and then the division property of equality, and we're done. We know that x is equal to negative 3. All right, so our other topic in chapter 2 was solving equations that involve fractions. And we're going to do these together. So if you are writing, it would be actually a good idea to copy this equation down if you want. 2 over 5x plus 5 over 20 equals 3 over 10x minus 14 over 10. Now, if you want to try this on your own, you certainly can pause the video here and just try it, see what happens. If you don't want to try this on your own, that's fine. You just want to watch. I'm going to solve it now. So we notice that each of these has a fraction, and we can eliminate the denominators here because the denominators are all relatives of each other. 5, 20, and 10, they all have something in common. That would be 5. So we wanted to find the LCD. That's pretty easy to do. The lowest common denominator, LCD, for this one would be 20. So if we multiply the entire equation by 20, over 1, of course, then some of these denominators are going to cancel. Actually, all of them will cancel, and some of them will leave us with factors that we can use. So let's look at the first term here. 20 over 1 times 2 over 5. 20 and 5 do cancel. 5 goes into 5 once, and 5 goes into 20 4 times. So we're left with 4 times 2. This is now 8x. Here, we multiply this by 20. 20 in the numerator and 20 in the denominator cancel, so we're just left with plus 5. Multiply this by 20. 20 and 10. 10 goes into 10 once. 10 goes into 20 twice. 3 times 2 is 6, so we have 6x. This 10 here cancels with this 20 once, twice. 14 times 2 is 28, so it's a minus 28. So we can continue to solve this equation by using our very straightforward properties. The first property we can use, there are many ways to do this. The first way that I'm going to do, I'm going to subtract 6x from both sides. 8 minus 6 is 2. 2x plus 5 is equal to negative 28. Well, we want all the variables on one side, and we have this in the way. Subtract 5 from both. 2x is equal to negative 33, and our final step would be the division property of equality, so x is equal to negative 33 over 2, and you could say that's equal to negative 16, not 17, negative 16 and a half. Okay, that's ugly. Negative 16 and a half. Cool. All right, the other option that we have when our denominators are not so easily related to each other is using benchmark fractions to convert our fractions to decimals. And we see here, I wrote out some benchmarks that we can use. 3 over 8x minus 2 over 5 equals 81 over 9 plus 3 over 2x. Well, 1/8 is 0.125. So 3/8, multiply this by 3, we end up with 0.375x. 1/5 is 0.2, so 2/5 is 0.4. 81 over 9, well, 1/9 is 0.9 with a bar, but 81 divided by 9 is just the number 9, so we don't need to worry about that. And 3 over 2x, 1 over 2 is 0.5, so 3 over 2 is 1.5. So now we have this equation. Not a very pretty equation, but it is something that we can solve. So the first thing that we're going to do, is start to combine our variables. We're going to subtract 0.375x from both sides. Negative 0.4 is equal to 9 plus, what would that be? 1.125x. Then subtract 9 from both sides. Negative 9.4 is equal to 1.125x, is 1 1/8 x if we were to write it as a mixed number. And if we were to do the division here, we would get negative 8.35 with a bar over just the 5 is equal to x. So that's a pretty gross answer, but there it is. All right. We have one more thing in chapter 2 we're going to go over, and then we'll be done. So we want to identify when there are no solutions and identify when there are infinitely many solutions. If we get a true statement when we're solving, it doesn't really tell us anything useful, but it is true, then we're going to say there's infinitely many solutions. And we see those in these two examples here. 6x plus 7 is equal to this whole mess. Well, if we simplify the right side, 8 minus 2 is 6, and 10 minus 3 is 7. So we get 6x plus 7 is equal to 6x plus 7. Oops, sorry, plus 7. And that's true. It doesn't help us at all. I mean, if we subtracted 6x from both sides, we would have 7 equals 7, which there's nothing wrong with that, but it doesn't help us at all. So we would say this has infinitely many solutions. This equation down here already we see that's not very useful to us, but let's say we added 3 to both sides. We add 3 to try to eliminate. Now we have 14y is equal to 14y, and that's true, but again, not useful. It doesn't tell us anything. So this has infinitely many solutions. If we're solving and we don't get anything useful, but it's also wrong, there's no way that could be, well, then there's no solution. So 81z plus 3 is equal to 81z minus 10. Well, let's say we wanted to move 81z to the other side, and that would actually cause them to cancel. And so we would have 3 equals negative 10. That's false. There's no solution. 2a plus 3a is equal to 5a plus 7. Simplify these. We get 5a equals 5a plus 7. Let's move this to the other side, minus 5a, and 0 equals 7. That is false, so we get no solution. All right, there is homework for this chapter. Please make sure that you do it. And if you're missing any of the previous homeworks, please make sure you're catching up on those as well. I will see you guys on Monday with a chapter 3 review. See you then.